Okay, so basically yesterday we started working on this, redoing the problem with the method 2. Okay, I'm not going to go again through it, and we stopped at one of the panels. I don't have the notes, but I think we were having a problem with one of the signs, no? So let me just restart from there and let's see what's happening, okay? So yeah, I don't think I have the problem here. Let me see, maybe I have it. Summer lecture. Yeah, doesn't look like I have the one from yesterday, but basically, you know, we're solving this problem over here, okay? All right. Not showing. Sorry for that, guys. So sorry for that. So basically, we're solving this problem over here. Remember the wing? I don't have it here present. So maybe I have it on the previous lecture. Yeah, so we had this problem, no? Correct? That we saw one method, then we found whatever, we made one cut right before the 2 meters, another cut right after the 2 meters. And then I started to make at the cut, we're looking at the shear flows in function of the Q12 in this. First, we did these 2 panels, and then we're doing this panel at the bottom, no? Okay? And I stop all this, and it's something strange because whatever happens here by symmetry should be the same thing at the bottom, no? Okay, so let me take it from there and let's see what is happening. So I don't have the notes from yesterday, but you let me know. So basically what's going to happen on this panel over here. All right, so let's see, this will be the side panel. Okay, here's where we have our stringer. Here we have the 33,343. And since I don't have the class notes from yesterday, I'm guessing that yesterday, so this will be here Q45. And this one will be Q34. So basically what's happening is that you need to switch the direction at the top and the bottom, because remember, the top is either compression or tension and the bottom one is either tension compression, but the opposite, no? Yeah? That's what we had yesterday?
Yesterday was going up.
Yeah, this one is going up, but this one was going probably to the left yesterday. Is that correct? Yeah, so it's Q45 that will be gonna, because this is top, this is the bottom, this is the top, no? Okay, so that's the reason. So the good thing is that you see I'm doing this live with you, so I find out my little mistake just because we know the symmetry, no? Okay, so I was able to spot it. So now if I do here at the node, I think that's the notation I used yesterday at this node. So at the node, what do we have? Minus 33.343 plus Q45 minus Q34 equal to 0, which gives Q45 equal to Q34 plus 33.343, which is going to give Q45 equal to, so we substitute, oh, so sorry. Okay, so it will be Q45 will be equal then to Q. We substitute by the value before that we have for Q34, which I guess is Q12 minus 77.457 minus 33.343, which will give you Q45 equal to Q12 minus 44.457. And that should be the same expression that you had on the top panel over here, no? Okay. I think like yesterday I had minus Q12 plus 44.457, no? Okay, and that's how we spot it. Okay, so now let's do the last panel. That will be the one that goes up over here. Oh no, we need to do the 2 meter ones at the bottom. So the next one will be, let's do this. All right, so we have this over here. Now following the same, we'll have over here Q56. Q45 and 44.457. So again, here at the node, we're getting 44.457 plus Q56 minus Q45 equal to 0. This is going to give Q56 equal to Q45 minus 44.457, which is going to give Q56 equal to what? Q12, the one from before, minus 44.457. Well, there is something wrong here. This is a plus here. Q56. So let's see. Yeah, this one should be negative. Now that works. So this would be now. So Q56 gives Q45 plus this one. We give plus 44.457. So this is going to give that Q56 equal to Q12. I think on the videos, I think it doesn't record this part, no, the videos, but it's so annoying. I know how to get rid of it. Okay, here we go. That's better. So now we do the last panel. That would be the last side panel. So will be, let's see, this one, this one over here, and let's do this. Oops. Okay. Oops. Sorry. All right, I'm going to look here at this one here. So let's see, we're going to have here the 33.346. We're going to have here the Q56, the Q16. And we keep doing the same thing. So at the node, we have what? Minus 33.346 plus Q16 minus Q56 equal to 0. This will give you Q16 equal to Q56 plus 33.346 equal to, so basically Q16 will be equal to Q12 plus 33.346. Okay, so on the previous method, what were we doing? We're doing basically make the cut. No, we did the same thing over here. But we do one before, one after. I mean, we didn't need a cut, sorry, but on the other one, we do a method. And then what do? We do summation of force equal to 0 and summation of moments equal to 0, no? Yes? Everything we have done here is what? Summation of forces equal to 0. What do we need to do next? To do the summation of moments equal to 0, no? Okay, so at the end, now we're gonna so let's say we always do the same thing. So equating internal and I mean it's always the same procedure and external moments. Oops, sorry for that. So as before, because this one I'll probably do this because we have the effects of the stringers about which point we need to take. About which point I'm going to take moments. About the center of gravity, no? Because that way the effect of the stringers is 0. So let's write it again. Because at the CG location, we're gonna have. I need to find out which notation I use over here. I think I did that last time, but I don't have the notes with me. So, oops. Let's see. Oh, here we go. That's figure. So I use for the PZ was eta and C. Okay. X, Y. X. And it doesn't matter which location we use. Oh, let me see. I use the same notation. That's why I did this. X. Okay. Okay, so basically the effect of the stringers is 0. All right, so let's do quick another figure over here. All right, so let me look at something here. Okay, the force is applied here at 1. All right. Okay, so let's remember here the dimensions. What do we have? So we are here. So I guess it's going to be 600 millimeters over here on the height, and then 600 and 600. Okay, that's fine. Everything is 600. I'll show you now my figure, okay, in a minute. Okay, so remember this will be the neutral axis over here, but I mean, we don't need it, but if you want, we can put it. Remember which was the direction of these ones. So 2, 4, 5. Wait, I did this wrong. It's 1, 2, 3, 4, 5, 6. All right, that makes sense now. So 2, 3, 4. Two, 4, 5. 2, 5, 6, and let's say here, whatever, Q61. So basically, what we have here is that this one will be very easy to do. What should be the moment created by the internal force? Will be Vy times 600. Okay, so let's see what I have on the code. So that's probably what I have. Internal will be Vy times 600. Okay. So this one goes clockwise, so we might have a negative sign. And now what will be the one due to the internals? Oh, sorry, this is external. This one is external, this will be internal. And I mean, let's see what I have here on the code so you can check, but what should we have? We should have each one of them. So Q12, you do top and bottom, so Q56 will be the same as Q12. It will be whatever, it will be this one times this distance times half of this one, so 600 times. Okay, so it's just, so the one will be Q12 times 600 will be the force, and the arm will be 300. Okay, the effect of this one will be the same of Q56, so we can put the 2 plus 2 Q23 times 600 times 300. I'm trying to follow the same thing that I have on the code. Yes.
Wouldn't Q12 and Q56 be opposite? Because our Q12 would be flowing.
Yeah, I mean, you see the direction here. This one, all the flows are here. I mean, if you follow the notation, we're just going from 1 to 2. Yeah, so it will be 1 to 2 over here. Yeah, I didn't pay attention to this, but if you do it this way, they will all be this way then. Okay. No, good point, good point. So I'm just trying to follow exactly the notation that I have on the code in case you want to use it. That's what I'm trying to do. That's what I'm looking at. So you see, I use 2 times Q1 600. I put 2, 3 instead of. Okay, it uses 4, 5. Okay, 2, 3, 4, 5 will be the same, no? Yeah, I put 4, 3, 4 in the code, but should be. And then 3, 4. Yeah, wouldn't you want to? I mean, what happens is that be careful here. I plot it this way, just go from 1, 2 to 3. Oh, this one will be also negative. Okay, then they will all be negative here as well. Okay, yeah. Correct. Okay. So equal to negative. All right. So I did these two tops, then we have plus 2, 3. Yes, I've done this plus now what? Q 3, 4 times what? 600. And what should be the arm? 1200, no? Because you go from here to here, no? Oh, no, it's the middle. It's the CG. What am I doing? To 600. Sorry for that. I don't know what I'm thinking. So let's check with this one. You see Q's And then we need to take the Q61. I was thinking about we're taking it to that age. All right. Yeah, I don't know. I was thinking we're taking it from here. Plus Q61 times 600 times 600. I could have doubled that one. Doesn't matter. So I don't have the notes from yesterday, but maybe you can put it over here. You can help me. So, for example, in here, Q23 is the same thing as Q45. So this one was actually equal to what? This one should be equal to what? From the previous page should be Q12 minus 44.457. And what do we have for Q34? This one will also be a function of Q12.
Q12 minus 77.8.
Minus 77.8. 77.8. Okay. All right. And then we have here the Q16. That's I have it on the nose. The one is Q12 plus 33.346. So basically, you see that the only unknown over here will be Q12, no? Okay. So solving summation of external equal to summation of internal for Q12. Okay. You're gonna get that Q12. So again, you see that's what I've done over here, okay? So for Q12 on the code. All right, so let's see what does that give us. Q12 is going to be equal to these are all the equations. So Q45, Q56 to Q12. Looks like this should be the equation here. I don't know. Is that one here? All right, so 63.895. Right, let me double check here. I should go over here. But you're probably right. Yeah. So we get Q1 to equal to 63.895. Okay, now finally, what do? You go back to all this equation that we derived and substitute back for Q12, no? Yeah, so remind me the equations that we derived. I think I'm missing probably a couple of them. And that way we substitute. I might have them over here, but they're not gonna be as pretty as so let's see. Maybe I have them. That way we check them. Let's see if I have them or not. Let me do something here. CLC. It might be easier to do this. That's why maybe doing sections might be better. I don't know if that's better or not. Oh no, because I already put the value. Okay. Let me do something if you don't mind. Okay, so maybe I have them here. So I think the equations we had, correctly, probably you have them on your paper, but I don't have them, so then we said the end, so substituting. Q12 back into, so what do we have? Q23. Correct me if I'm wrong, Q23 would be equal to Q12 minus 44.45, whatever, 7. All right, I'm gonna start summarizing. Q34 is equal to Q12. What do I put Q1 for? Q12 minus 37.8. That one I remember you told me before. Q45 is equal to Q12. That one already have it, minus 44.457. Q56 we derive today is equal to Q12. And Q61 or 16 equal to, so Q16 is the same thing. Q12 plus 33.346. Okay, so this one will be 63.895, same as Q12. 63.895. Q23 will be equal to what? The what? Move it up. Yeah, sorry for that. Then I probably need to run out the values. Let me go back to the code. Then I can run everything ready. So F5, and that should give now the final values. Okay, so let's see. All right, so Q61 gives 97.237. Okay. This one is 63. Q45 will be 19.438. Q34 will be negative 13.904. Q23 19.438. And Q12 we already know there's 63.895. So these results over here should match, and I think they do. I think we checked that yesterday, but basically should check the solution that we did with this one using the classic approach. So maybe lecture 13. I need to do some scanning over here. So let's see, we need to match these values over here. So you see it's kind of a bit different. No, that is not going to match this. It's going to match the values that we get yesterday, because remember we said that it was for case 1, no? We had a problem. So let's go back to the MATLAB, even though I'm pretty sure we did check yesterday. All right, so let's file open method 1. Analyze. All right. Over here. And yes, you see we have doing the same way. We have the 97, the 19.44, the 13.88, and so on. No, they are pretty close to each other. Okay, so basically you have this on the videos. I'm going to go slow again. if you want to use these codes, you know, but you're gonna have to type them. So this is for the method we did it last time. But again, you might have to modify them. It's probably what I'm gonna do next. And then for this one here, method 2, I don't mind to show it to you what I've done, okay? But again, you need to modify them. Okay, so that's it. So now what we're going to be doing is we are going to start working together on the assignment 4. All right, so I'm going to do it. I'm going to try to put it on the code. I mean, it's going to be hard. The people that are online are going to be able to see everything I do, but it's nothing I can do. Okay, but basically this is the one. And let's see if we can compare some of the values. So initially, you see it was to do this at the wall, but now we need to do it at the middle. So if you didn't you do this one for the previous assignment or something similar? Okay, so the whole idea is to develop your models now, so you can use them over and over, no? Do a type modification. So in this case, it was at the wall, but I changed it yesterday to put at 75 inches. So right in the middle, like we did for this one. Okay, so method 1 and method 2, no? So start working on it. That's all I can say. I'm gonna stop the video for a minute. Then I'm gonna start working on it. I don't mind to record to show what I'm doing. Let me just pause. Why can I pause this? Because I'm gonna give you back the exams.